Hello everyone, welcome to my YouTube channel MK Maths. I am Karthik Mansali. In last video we have discussed the 3 marks question problems. I have in previous two videos I have covered 3 marks questions, that too based on equivalence relation. So the question may arise so that R is equivalence relation. So I have covered those important questions. You have to you check my previous videos so that you will understand how to solve that 3 marks question when the question given R is a equivalence relation. I have used the target for reflexive relation, what we should do for a symmetric relation, and what we should do to show a symmetric relation, and to show transitive relation, what is our main target to prove. So I have explained detail in those two videos. If you watch those two videos and if you practice those examples, then definitely you are going to get a 3 marks question. So sometimes they may ask this question also, this type of question also. In this video I am going to explain about this type of question here. So here the question says, if you have any doubt in my video, or if you got any doubt, please do comment so that I will get to know what doubt you are facing. I will try to clarify in next video, or I try to clarify in comment section only. Okay, so let's start so in this question, show that the relation R, same they have given a R, we have to show this relation R in the set R. So don't confuse with these two R's. Here the first R is relation, just I have written R. See the symbol, see the shape and see the design. I have written R. So English alphabet letter, capital letter R I have written. But in the set R, when I mentioning the set R is nothing but a real numbers. So when I mention a real numbers, I write that R in a stylish way. In stylish way I have written, in bold I have written. So see, there will be difference between this R and this R. If you observe in textbook also, there will be a difference between a relation R and a real numbers R. So don't get confused which R here is a reflexive, which R here is a relation and which R here is a real numbers. So there will be a light difference in the symbol. I hope you understand. This first R is a relation, and in the set this second R is a real number. So this relation is defined in a real numbers. So in previous question the relation R defined in a integers. In same way they have given a real numbers here. Okay, defined as that R, relation R defined as ordered pair A comma B. Okay, here again they have given ordered pair A comma B. It means ordered pair A comma B means A is related to B. So how the relation is exist between A and B means the next part they have given. See, this is such that A less than or equals to B square. So this is the relation. If you want to say A is related to B, if you want to say A is related to B, then A should be less than or equals to B square. If you square the B value, then that B square value should be should be bigger than A or equal to A. That is the meaning. I hope you know this symbol meaning. So if you written this less than or equal to symbol, if here this part has opened mouth here. So just to remember easily I am saying this. So here opened mouth, this part is closed mouth. Just think as a mouth is closed. Okay, if mouth is opened means we should write here a big number. So in this place we have to write big number. Here mouth is closed means in this place we have to write a small number. I hope you understood this. So if the symbol is like this, I have written 10 here and I have written 20 here, then it is not true, because in this place, because mouth is open here, in this place there should be a big number compared to this, but here 20 is there, here 10 is there, which is not true. Okay, so less than, greater than, for some of students will get confusion. So I have explained in this way, so it is easy way to remember. Okay, so now let's start the question to solve. Show that we have to show neither reflexive nor symmetric nor transitive. Neither, they have used here word neither. In previous question they have used R is a equivalence relation, so that it is easy to show. R is a reflexive relation, R is a symmetric relation, R is a transitive relation. That too we have showed by changing just for to show reflexive relation, we have changed in the place of b we have changed a. To show symmetric relation, we have just interchanged a and b. To show transitive relation, just we have eliminated b and related a and c. We have just interchanged, we just changed the some a b c, some values, some ordered pairs, that's all. But when it comes to show negative way, not r is reflexive, here we have to show r is not reflexive, we have to show r is not symmetric. To show r is a symmetric is easy, but to show r is not symmetric, we have to change the method to solve. So to show r is not, so to show r is a transitive is easy, we just eliminate the b, we just eliminate t2, we just eliminate l2, like that we just eliminate the middle part and we relate a first and last, it will be transitive. But to show nor means not negative way, we should show r is not transitive. So let's divide these two questions. To show r is a reflexive means just we have to change in the place of b a. Okay. To show r is not reflexive means we have to find one example which does not satisfy this r. We have to find one a b values which should not satisfy this given relation. We have to find, we have to search. So it takes a time. So it takes our time to find which a and b is not satisfying this r. To find, we have to find in real numbers. So they have mentioned a set r real numbers. So real numbers has a infinite numbers, uncountable, because real number is uncountable numbers. So we have to find a value, b value, c value, whatever, to fail this relation. Whatever the values we have found, it should not satisfy the relation r. We have to find, though then only we can say r is not reflexive, r is not symmetric, r is not transitive. Okay, I hope you understood. Let's start with the by finding example. Okay, so first I write here solution. No, first our target reflexive. So reflexive topic, I have to show r is not reflexive. Okay, so let's start with examples. So if you observe here, a less than or equals to b is there, a less than or equals to b is there, obviously b square will be greater number in real numbers. If you take any value 2 3 4 5 6, if you consider any one value, because reflexive means there will be no two values, you have to consider only one value, you have to square that value. After squaring that value, you should not get a small value. So that is our target here. So if you consider anyway, for example, if I consider 3, if I consider 3, and if I substitute in this relation 3 less than or equals to 3 square, obviously it is satisfying. If I consider 5, okay, 5 less than or equals to 5 square, obviously it is satisfying. 5 square will be greater than 5, 3 square will be greater than 3, obviously satisfying the relation. But we can't conclude it is a r is a reflexive relation, because to say r is a reflexive relation, it has to satisfy each and every element of this real number r. So we are just finding 1 2 3 values, those are satisfying, but remaining values we have to find a value that which does not satisfy the relation. So don't consider the whole numbers, try to find the example in fraction value. So fraction means like this, similarly 1 by 2, 1 by 3, 1 by 4, because if you square this 1 by 2, 1 by 2 less than or equals to 1 by 2 whole square, 1 by 2 whole square. Now it will become 1 by 2 less than or equals to 1 by 4. 1 by 4, see here in this line, if I consider here 1 by 2, 1 by 4 will be before 1 by 2. 1 by 4 present before 1 by 2, it means 1 by 4 is the smaller number compared to 1 by 2. But here 1 by 4 in this symbol, in this relation saying 1 by 4 is a bigger number compared to 1 by 2, which is not possible, which is not true. So we have to consider a fraction to fail this relation. We have to consider fraction to fail this relation. So here I am considering a fraction part. Better you remember this question whenever they ask a less than or equal to b square, and they ask to show neither reflexive nor symmetric nor transitive. Just remember each value to fail a reflexive, to fail a symmetric, to fail a transitive, then it will be easy to write in exams. Okay, I hope you got it. So first let Let us consider. So we have to consider first number. So let us consider what I have considered. What will I consider here means, so here I consider 1 by 2. Okay, 1 by 2 which is belongs to set R. Okay, from real numbers I have considered 1 by 2. So and I'll check the given relation, it is satisfying or not. Okay, so 1 by 2 less than or equals to 1 by 2 whole square. 1 by 2 less than or equal to 1 by 2 whole square. Definitely it is not satisfying, because I have said 1 by 2. If we 1 by 2 present here means 1 by 4 will be previous of 1 by 2. It means 1 by 4 will be always less than 1 by 2. So which is not true. So which is not true. So if it is not true, then easily we can conclude this 1 by 2 comma 1 by 2, this 1 by 2 comma 1 by 2 does not belongs to R. This 1 by 2 comma 1 by 2 does not belongs to R. If it is does not belongs to R, then R is, we can easily say R is not reflexive. R is not reflexive. I hope you understood the reflexive part, how we should show R is not reflexive. Here I have considered the fraction part 1 by 2. You may ask why we considered fraction part 1 by 2 means our target is to show that R is not reflexive. Okay, I hope you understood. So fraction part is the best example to fail this relation. So I have considered 1 by 2. You may consider 1 by 3, 1 by 4, anything. So if we show one example, that's enough. Okay, if we show one example that fails the relation R, that's enough to say, that's enough to conclude R is not reflexive. I hope you understood this reflexive part. Let's move to symmetric. Now how to conclude a symmetric is not symmetric. Okay, symmetric. So the our relation is like this: a less than or equals to b square. We have to our relation is a less than or equals to b square. Okay, a less than or equals to b square. Here we have to fail this relation. We have to fail this relation. That type of a and b we should find. Okay, so let's find a comma b here. So if we take small number here, first I take a small number here 1 and big number here 1 3. So if I consider 1 3 or 1, better to remember take 1 2 only, because next I will say. So if you 1 3, if you take 1 3 also, it will be symmetric will be fail. Okay, so R will be not symmetric. So I am considering here 1 2 because it is easy to remember. So I am considering it as a 1 2. So 1 a less than or equals to b square means 1 less than or equals to 2 square. Okay, it satisfies. It means 1 comma here, because 1 comma 2 which is belongs to R. Okay, well and good. We have to consider first actually 1 comma 2 which is belongs to R. We have to consider ordered pair first. It should belongs to R. When we reverse the ordered pair, then it should not belongs to R. Then only symmetric definition will fail. If the symmetric definition is failed means then R will be not symmetric. Okay, so now interchange this 2 I am going to write here, this 2 I am going to write here, less than or equals to this 1 I am going to write here. So 1 square, this 1 I am going to write here. So this one I am going to write here. So 2 less than or equals to 1 square, it fails here. So 2 less than or equals to 1, which is not possible, so it fails. So 1 comma 2 is there, but when it comes to 2 comma 1, it failed. It is not present in R. So it is the best example to say. So to show how to write R is, how to show this say R is not a symmetric means, first we have to consider let 1 comma 2 belongs to R. So we have to consider 1 comma 2 belongs to R means 1 comma 2, 1 is related to which is present in R, because it satisfies. Therefore it satisfies 1 less than or equals to 2 square, it satisfies. So 1 comma 2 belongs to R. Now our target symmetric is interchange. We have to interchange and check. So I am just interchanging 2. I am writing 2 here first, less than or equals to. I am writing 1 here as a first. Here it fails, which is not true. So which is not true. So when it is not true, we can say ordered pair 2 comma 1 which does not belongs to R. Ordered pair 2 comma 1 which is not belongs to R. Therefore R is not symmetric. R is not symmetric. We can conclude that R is not symmetric. So why I have to care 1 comma 2 means in reflexive we have used 1 by 2. So it will be easy to remember 1 2, no. So in symmetric also use 1 2. Those numbers only. 1 by 2 for reflexive, 1 by 2 for symmetric, 1 2. So it is easy to remember this problem. There will be no any extra effort to remember. Okay, so if you remember 1 by 2, then definitely while solving a symmetric you will remember the number 1 2. So if you consider a 1 comma 2, it will satisfy, but when you interchange the it as a 2 comma 1, then it is not going to satisfy the definition, symmetric definition. So it is does not belongs to R, so it is not symmetric. I hope you understand the symmetric. So let's move to transitive now. So transitive, our next part is transitive. So for transitive we have to take 3 numbers. So A to B, it should be relation A is related to B and B is related to C. Then we have to conclude about A is not related to C because R is not transitive. We have to show R is not transitive. We have to find an example which is not related from first element to last element. We have to consider that type of elements. So start with big number. So we have A, B, C. There should be relation from A to B. Okay, there should be relation from B to C. We have to find that type of numbers, but there should be no relation from A to C. Okay, so let's find now. So start with big number 10. 10, and if you consider here 2, we consider 2. Why I am considering 2 means, just think, if you square this 2 square, then it becomes 4, which 4 will be less than 10. So it is not satisfying the definition. So it should not satisfy. No, A less than or equals to C square should not happen. So he should not happen means A should be big and C square should be small. So this is our target. A should be bigger number. After squaring C, it should be a small number compared to A. So that's why I have taken 2 here. So in middle you can consider which satisfies both. You can consider. So I consider 4 here. So 10 less than equal to 4 square. 4. It will be satisfied now. So let's take now. Let 10. I started with 10 and ended with 4 here. 10 comma 4 belongs to R because it satisfies the definition. 10 less than, here we can write 10 less than or equals to 4 square. Okay, easily. And next, and we have to consider 4 comma 2. Okay, 4 comma 2 belongs to R, and here it's satisfying. 4 less than or equals to 2 square. Here 2 square, here we have equals, so nothing, there will be no problem. 4 less than or equals to 4, it will be satisfied. If there is no equal sign, then it is not true. 4 less than or equals to 4, it is not possible. So equal sign is there, so no problem. 4 less than or equals to 4, it is satisfies. But so compare first and last now. When first set 10 and last C square, so will be 2 square. You consider 10 less than or equals to 2 square, it fails now because 10 is not less than or equals to 4. But here our relation says 10 less than or equals to 2 square, which is not true. So just write which is not true. If it is not true, then this first element 10 and last element 2, which does not belongs to R. If it does not belongs to R, then we can conclude R is not transitive. R is not transitive. Okay, I hope you understood this this question. So another one question is there. Same way they may ask here. They ask they ask here a less than or equals to b square is there. No, they ask a less than or equals to b cube. Same question, same, they mention all same in real set relation r in a set r defined r equals to order pair a comma b, such that they mention a less than or equals to b cube. In the place of square they mention cube. So just observe here, in the for b square only it is not satisfied reflexive, it is not satisfied symmetric, it is not satisfied transitive. How come the cube will satisfy? So definitely the cube will also not satisfy the reflexive, not satisfy symmetric and transitive. So use the same examples to solve problem. So here for example reflexive we have taken, so 1 by 2 belongs to r, 1 by 2 less than or equals to 1 by 2. In the place of 2 just write cube here, 1 by 2 whole cube, so which is not true. 1 by 2 comma 1 by 2 does not belongs to r is not reflexive. Okay, next when it comes to symmetric, take same example, 1 comma 2 belongs to r, 1 less than or equals to 2 cube here. So we have changed question, so 1 less than or equals to 2 cube, and now interchange 2 less than or equals to 1 cube, which is not true again, which is not true. 2 comma 1 does not belongs to r is symmetric, everything is same. So just in the place of square just substitute cube, then the another problem is solved. So next transitive, so 10 comma 4 belongs to r, 4 comma 2 belongs to r. So see here in the place of 2 you substitute 3, 10 less than or equals to 4 cube, okay, it satisfies. So 4 less than or equals to 2 cube, okay, it is also satisfies. So 10 less than or equals to 2 cube, which is not satisfies, because 2 cube means here 2 cube is nothing but 8, which is still less than 10, so it is not possible, which is not true. So 10 comma 2 does not belongs to r is not transitive. So by understanding one problem, then you can solve two problems, a less than or equals to b square and a less than or equals to b cube. Same problems, same thing. So you have to just remember, for reflexive 1 by 2, okay, for symmetric 1 comma 2, for transitive 10 4 2, 10 4 2. For both these examples work for both a less than or equals to b square, a less than or equals to b cube. I hope you understood this example 1 by 2, 1 comma 2, 10 4 2. So in next video let us meet. So up to now practice these two types of question which I have mentioned. R is equivalence relation, and in this type of question I have mentioned neither r is show that r is neither reflexive nor symmetric nor transitive. Like if any question contains negative, if any question contains neither reflexive, show that r is not reflexive, show that r is not symmetric, like that of question. Not is present means we have to consider one example to fail that relation and to show this example, this a comma b, this x comma y is not satisfying the given relation, then definitely it is a not reflexive, it is not symmetric, not transitive. By just showing one example you can conclude not reflexive, not symmetric, not transitive. But to conclude r is reflexive, r is a symmetric, r is a transitive, you have to verify for each and every element in set r, each and every element in given set, whatever the set they have given, you have to verify for each and every element to say it is a reflexive, to say it is a symmetric, to say it is transitive. But when it comes to say negative, when it comes to say not reflexive, not transitive, not symmetric, then you just find one example, simple small example. If it fails the given relation, definitely directly you can conclude that r is not reflexive, r is not symmetric, r is not transitive. Okay, I hope you understood these problems. If you got any doubt, if you have any little doubt, or if you need any little clarification, just comment me so that I can get what your doubt is there. So definitely next video or in comment section, definitely I am going to reply you all. So yeah, I hope you are doing well. I hope you are doing well. So let's all meet in next video. Okay, up to then, bye bye.